Good morning. This is a supplementary video to help you to do the assignments on ADTs. I am sure all of you have started your assignments on the using abstract data types in solving problems. So, I thought what I will do is I will walk you through some examples of using abstract data types to solve problems. Just to recap, what is an abstract data type? It is similar to a procedure, and just as a procedure generalizes the notion of an operator, instead of using operators like plus, minus, star and division, you define user defined operators. And also the data on which the procedures operates can also be user defined data types. So, just as in a procedure, for example, you can encapsulate functionality, ADTs are used to encapsulate data types also. All right. So, basically what I mean is, if you are using, for example, the cin function or the cout function in C++, you do not have to know how cin is implemented in the class std, you just use it as long as you know how to use it. Okay? That is basically the idea. An example of an ADT, user defined ADT, is a matrix, and it has operations like addition, subtraction, multiplication and inverse defined on it. So, generally when we are talking about ADTs, we are talking about a mathematical model. For example, when you talk about matrices, you can give a mathematical model, you know it is a two-dimensional array, and there are informal algorithms to show what is the multiplication of the matrix, what is the addition of a matrix, what is subtraction, how do you compute inverse and so on. Then what we do is, when you a more computer science way of looking at it is an abstract data type and a pseudo language program. Now, finally, when it goes into the actual programming language, you have to use a concrete data structure to represent this mathematical model of a matrix, which is kind of more closer to the programming language in an abstract data type, and then the corresponding operations that are performed. You had an informal algorithm here, here you have a pseudo language program because it is not language specific. Finally, you have a corresponding concrete language over here. So, from here to here, the difference is essentially that you define it in a language independent way over here, and here it becomes specific to the particular language. Okay? This is what we saw in the lectures. So, basically you have a data model, and from the data model you go through some intermediate step, which is like a abstract data type and a pseudo language program, and then you do the implementation of the abstract data type in a concrete language, and the corresponding algorithms become higher level language programs. So, now what we in this part of the course we have decided to use C++ primarily because C++ lends itself naturally for the implementation of abstract data types. So, we looked at, if you remember in the course, we looked at the ADT list, stack and queue, and I am going to straight away go to the list which we talked about. And what did we say? It is simplest kind of abstract data type that you can think of. Basically, it is a list of n elements, and the elements are of some element type, n is the length of the list, and first element is a1 and last element is an. And what is interesting about the list is that you can, if you want to define it as an ADT, that is going closer to the programming language, you will say A is a list of element type. Notice that in the ADT here we have not talked about what the implementation is, and then what are the various operations that I want to perform. I want to insert an element into the list at some particular point. Going back to this example over here, I have a list of elements A1 to A, and suppose I want to insert an element somewhere in the middle. How would I go about doing it? Okay, talk about that. And this, I want to go to the end of the list, that is after an, I want to go there because I might want to do some operation there. Locate, I want to find an element in the given list. Okay, and retrieve, I want to retrieve an element. Let us say I have a position, let us say 3 over here. At position 3, what is the element that is there in the list? Delete, I want to delete an element at the position 3. Next, for example, find the position of the next element in the list, and so on. Okay, previous get the position. You wonder, why do I want this? Okay, when I look at next and previous for that matter, primarily because we do not know what the underlying implementation of the list is. Okay, the list could be implemented using arrays or linked lists, and we just want to know where is the next element located. or I might use something called a node space where I have multiple lists that are located, and basically you need indexes to point to where these elements are located. So, this is figuratively showing what a list looks like. So, the two different kinds of data structures that we have for implementing lists is an array and a linked list. Okay. Remember the course we did using the linked list, if I remember right. Okay. So, what did we do over there was we said, we did the implementation using the linked list. So, basically when you look at lists, for example, using an array, one corresponds to the first element in the array, and let us say this is the max length of the array, and as you keep inserting elements, you also have a pointer which points to the last element in this list. Okay. If you are using a linked list, for example, you have a pointer to the header that is necessary, and last, if you want, you can have a pointer, or you need not have a pointer, and you keep inserting the elements as and when required. Okay. So, what did we do in the course now? Let me, I am going to take you through the code that we have here. Let us look at this. I have two implementations over here. I am going to look at the, so basically we said I can, in the course, for example, we did the pointer based implementation. Now, let me see if I can, okay, just enlarging it a bit so that you can see it better. Okay. So, this is the, just one moment. Okay. So, we have this list over here. Notice that this is a pointer based implementation. Notice that in this particular case, I am having a list of integers, and here is something which is called element type, and element type is defined by the user of the list, whoever is writing an application using list. And here type def struct cell star pointer is position. Position, for example, becomes the address of the next element, as we saw. Okay. If it is an array implementation, the address becomes an index. Okay, it becomes an integer, and then the various operations are given over here as indicated. Because I have written this in C++, I have used del item instead of delete, primarily because delete is used for specifically deleting an element in C++. Okay. Then there is something which makes an empty list. It creates create a dummy node, as we saw in the class, and insertion, for example, inserts an element at a position p in the given list, and prints the entire list, and list end points to the end of the list. Let me kind of explain what we mean by this. Delete, for example, notice we have done this over here. Notice it is a single operation. Normally, for example, when you look at a linked list representation, you have to go to a particular position by to locate the position p and remove the element at a particular position p. You have to know the pointer of the previous node. What we do in this implementation is we are a little clever, and what we do is we create a dummy node, and when you say insert at a position p, we insert at the position next to that p. What we mean by that is the following. What we are doing is, so there are two implementations, as we already saw. We saw the array and we also had list. So, what we do is we create a dummy node first, okay, when we create a make null. Then when we say insert at, let me say this is the position p at which I want to insert. What we do is the user knows what he or she is doing. Then what we do programmatically is we insert at this point and point this back. So, obviously, when the user wants an element to be retrieved, let us say this is 5, 6, 8 and 10. So, initially it contained 5, 6 and 10, and you said please insert an element at position p. You know that it corresponds to the next element. It is not when you want to, this element, for example, can be retrieved or accessed by a pointer to this. Okay, you do not have to worry about it. So, we take care of it internally, that whenever we insert an element, it is always inserted at the next element. Primarily because, remember when we did the data structures and algorithms, we said time complexity is a very important criterion. So, in this algorithm, by creating one simple dummy node, we make the delete operation an order 1 operation. Okay, all right. So, this is basically the idea. It gives you, and there are various operations that have been performed. Now, what I am going to do is, this is the linked list implementation. Okay. Now, I am going to walk you through the array implementation of lists. Okay. Now, let us see this one. All right. Okay. Let us look at this now, and what will you see now? Notice the type def int element type remains the same because this is a list of integer elements. Notice that position becomes integer now. It was a pointer to cell type before. Okay. And then notice the operations. The operations look identical. They do not look different at all. So, the user of the list, the person who is going to use your list to write programs, can use either this list, either the linked list implementation or the array implementation. Okay. Then what are we doing here now? We are creating make null, for example, creates an array of 100 elements, and the rest of the operations are very similar. And when you asked for a if you are inserting, for example, in the array, and this is the position of the last node, what do we do now? If you want to add an element to the list, if I let us say at a particular point P, I want to put an element here, then this last node must be moved here and put the element here, and all these should be moved downwards. That is exactly what is achieved. When we talk about the end, this is the end of the list. Similarly, when we talk about the end, this is the end of the list. Okay? That is what we mean in this, as long as we are consistent. End means end of the list. Okay? All right. So, we do this, and now what I am going to do is, we will look at, I want you to, I will open it in the programming window so that you can look at it carefully and understand it. I want to open these two programs together and show you something. Okay. Okay. So, I am opening both these programs. You have the list which is represented using an array and the list which is represented using a so basically is the same implementation that you have. I want you to look at this part where we have the same main program. Notice this over here. If you observe this over here, we create an empty list and we are inserting 10 elements into the list at the end of it. So, initially where is end now? End is pointing to the 0th element. The indices are starting from 1 in the array, although in C++ it will allow you to start with 0. What am I doing? I am inserting I into the end of the list, same program over here. Then what are we doing? We are saying print the list, delete item, delete the first item in the list, print the list, delete item, the next of the first, and again print the list. Okay. So, let us run these two programs and they should give us identical results. Let us see how this can be done. Okay. So, what do I mean here? So, what did we do? We inserted 10 elements into the list. So, this is what was done 0, 1, 2, 3, 7, 8, 9. Then what did we do? We said delete the first element, so the 0th element is gone. Then we said delete the next to the first element, which is the next to the first element 2, therefore, it has got deleted. Okay. Now, let us look at list ptr. List ptr also does the same thing. Remember, the main program was the same. In one case, we have used the array implementation of the ADT. In another case, we have used the linked list implementation of the ADT. It simply does not matter. What is important is the main program is an application that uses an ADT list, and as long as you are consistently using the same ADT, it does not matter. Now, in the assignment, what you would see is that somebody would have given you a particular list implementation and they ask you to use that implementation in the program. Okay. Now, one of the things, the two of the problems that are using lists in your first week's assignment are begin, and the other one is the hash tables. Now, what I am going to do is, I am going to show you one more example and then I will go to the assignment problems. Now, what we have, so far what we have seen, we saw the array implementation and pointer implementation, and we saw that the main program is the same irrespective of array or list, primarily because we do not operate on the data which is internal to the ADT list. That is the fundamental point. Now, what we will see is how can I use an ADT list that has been defined to do something else. Okay? Can I use a list to make something else? By now, many of you might have seen the stack video. What is a stack now? A stack is essentially, as we saw in the course, what did you see about the stack? The stack is essentially a ADT where you insert at one end and delete at another end. And we also looked at the conversion of infix to postfix in the stack. Okay, the next video actually explains how this is done using the ADT stack. Now, in a sense, the stack is also a list. While a list ADT allows you to insert elements anywhere, delete elements anywhere, okay, a stack on the other hand allows you to insert at only one end and delete only from the same end. Therefore, we call the stack a last in, first out data structure. Okay? Last in, first out. So, if I insert elements into the stack, for example, suppose this is the stack, stack is empty, and again you can have a linked list or an array implementation and so on. Let us say I have inserted 5 elements into the stack. So, this was the stack was empty, I put this first element, then push this second, third, fourth and fifth. Now, if I pop the elements from the stack, what are we going to see? It's going to pop 5 out, then it's going to pop 3, 2, 1 and 0 in reverse order. Okay? So, basically that is what we mean by last in, first out, and as you all know, a stack is something that is used, which you might have either read about or heard about. In fact, a stack is something that we are always using even in practical life. Okay? Programs, for example, when you have functions or recursive functions in particular, what is done? It puts everything on the stack, the recursive function calls itself again. You already seen the C part of the program where you did recursion, and finally what happens? The last recursive call completes and then all the others complete in sequence in the reverse order. Okay, this is what we have seen in stacks. Okay. So, now let us see, but stack is also a list. So, can we implement a stack using a list ADT, and that is what I am going to talk about. So, let us look at this example. Okay. Let us say I look at stack from list is what I am calling this program. So, what I am doing over here is I am assuming that I have a list which is already implemented, and what we are doing is we are trying to make a stack out of it. So, what am I doing here? I am reusing the list. So, if you look at it over here, there is a class list which we already defined with a set of operations which are defined on it. And now, I want you to see what I have done in terms of implementing the class stack. What am I doing when I am implementing the class stack? I am representing as part of its private data a list L. That is, I am including a data type which is of type list L. Remember, there is an ADT that I am defining over here. Then what are the operations I want to implement? Pop, top, push, empty, make none. We know all this, right? So, now what we do is, what is the meaning of top then? Top should correspond to retrieve the element I am using. I am always inserting at the first element and popping from the first element. Okay. So, top means for me corresponds to L dot first in this implementation that I have. So, I say retrieve the first element from the stack. What is pop now? It not only retrieves the first element, it should also delete the element at the first position. Okay. So, basically I am using list operations to perform the stack operations. Okay. Now, what is insertion now? Notice that when I am pushing at the first element. Okay. So, what is happening now? As we keep, if I go back to this list over here, so what are we doing when we are making this a stack? We are simply doing the following. So, this is what we have as the list. I have purposely used a linked list implementation here. It simply does not matter. So, when we say insert at first, it is going to keep. So, let us say initially I had nothing, then I inserted 1. Okay. Okay, I pushed 1 into the stack. Now next, if I want to push 2 onto the stack, what I'm going to do is I'm going to put it here, and then this will be moved forward. Okay, this is the meaning of the stack list being used as a stack. Okay, so next, if I want to push the element 3 onto the stack, then what am I doing here? I'm using the list like a stack, so I'm pushing the element 3 here, which will point to the element 2. Notice that 2 and 1 are being moved ahead in the list. Okay, so now when I want to print all the elements in the, or pop all the elements in the stack, what is going to happen? It's going to put it in reverse order, and that is what we will see in this particular example. Okay, so let's look at this program over here. So what have I done now? I have not done anything. I have just simply implemented the stack using the list which we already know about. So let's just look at this program over here. So I have a stack A. The stack A has been implemented, as we already saw, using the list ADT. Okay. Then what am I doing? I'm creating an empty stack, and then I'm pushing elements 0 through 9 into the stack, and then what am I doing? I'm popping out all the elements that are there in the stack. So what do we expect when I'm pushing them? I'm pushing them 0 through 9. Okay. So when I pop them, it will come out in the reverse order. Then it behaves like a stack. So let's see this particular example. List, this is what it's doing. So notice that we inserted from 0 through 9. Okay. So first there is an initialization of the stack, and then we inserted it, if you remember right. And finally, when I pop the elements from the stack, which is what I printed, it is coming in reverse order. Okay. So I hope you understand what we have done over here. So what did we do? We said pushing the elements 0 through 9, and then what are we doing? We are printing the elements that are popped off the stack, and this is what we saw. Okay. All right. So this kind of should give you an idea about how to use an ADT in a given list. So now let's get on to the two problems that have been given to you to solve using lists. One was the big int problem. Another is the hash table problem. Okay. So let's look at each one of them in detail. What is the big int problem? They said a particular definition of list is given in your assignment. The reason for giving that is you should be able to use any user defined ADT. The definition of list can be different. Again, it's a list of elements, and how do we use that list of elements to perform what is called big integer arithmetic is what we said. So what is being done over there in that? We essentially, that means this big int is actually operating on large numbers. Let us say I have a 10-digit number. Okay, 1, 2, 3, 4, 5, 6. Okay, let's say I have a 10-digit number, and something like this, and I want to find the product of two such large numbers. Okay, it may be, I won't take two exactly the same size numbers, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say I have 5, 3, 2, 1. So on. Okay, let's have something like this. So the problem is many of them will. So obviously, if you're running with a 32-bit machine or even a 64-bit machine, computations of this kind cannot be done because the numbers are too large. So how do we use a list to do this? We can create a list, does not matter whether it's an array or use a list ADT, and we can create a list of all these numbers. So what we can do is, you can use, when you're writing a program to compute, let us say you are asked to find the sum of these two numbers. Okay. So what do we have to do now? So we have to add these two numbers. Okay. Then if there is a carry, then this should be carried over here, and so on, and repeat this process, and maybe the number becomes larger than this 11 digit over here, and you have to make that happen. Okay. So what we do, the way to do this using lists, I am just going to give you an idea here. What we want to do is you create a list with the elements, okay, 9, 7, 6, 5 and so on. It may be actually convenient to put them in reverse order. I am not going to give you the details why you would do that. And then what do? I have 5. This number is written like this, 2. That is, every single digit number is put into made an element in the given list, okay, and so on. Have 1. It will be convenient to put it in the reverse order because then the first element becomes the first element in both the cases, otherwise you have to go to the end of the list. Anyway, it's a little bit more of bookkeeping, that is all. So what do? I perform the sum between these two elements. So your objective is to define a new ADT called BigInt, which uses a definition of list that is given. Remember that there are append, prepend and so on and so forth, various kinds of operations where you can prefix or even suffix and so on and so forth. Okay. Append is put it to the end of the list and prepend is put it at the beginning of the list. We compute these operations over here. Then what do we have to do now? This will generate, for example, suppose this was 9, then what will happen? I basically, if I am using this version of the list, I have to pick both the last elements in the list, then I bring them out because their element type, I know what they are, because I was as a user of this to build the BigInt, I gave a string of 2 integers. So what am I doing? I am writing it as a string. Then I have to do the conversion, so on and so forth. Then we perform this arithmetic. So 9 plus 1, okay. All right. Now this will be 10, right. So 10, what's happening? 10 means there is a 0 followed by a 1, okay. So what is this now? This is the number that goes into that and there is a carry. Now what should you do? You have to propagate the carry, okay. So what do? We take the previous element of the last, add the 2 of them and add the carry to this. You keep repeating this until you move to the end of the list. So the BigInt problem that has been given is primarily a particular definition of list has been given, to which you have been asked to add some code, write some code, and the operation that is expected to perform is the sum of 2 large integers, okay. So what will you do now? Once you got the result, again the result possibly cannot be represented in an integer variable in the computer. So you have to again convert it back to string and give the result, okay. So that is the important point about the BigInt ADT, okay, that you were asked to implement. Now let's look at the hash table. What does the hash table tell you? It says that you are given, hash table is defined for you. Now notice that BigInt is using the list to store large numbers. Okay. So what did we do? We took these 2 strings, took the numbers as strings, took all the characters one by one, each one of the characters is digits, and put it in a list. That is what we did. Okay. And then we use the list to perform operations on the list, get elements out of it, then perform arithmetic, put it back to the list. That is what we did. In the hash table, it's slightly different. What does it say? That the hashing is defined. If you're given a set of numbers, let us say 99, 25, 33, 65, 75 and so on, you were asked to, these are called, let's call these the keys, and you were given a hash function which said x% 10. So that means when the key is x, let us say, and you're taking the remainder when it's divided by 10, it goes into an array. Okay. And this array has, how many elements can it have maximum? Clearly, because this is %10 and we are doing in base 10 over here, so the numbers, the remainders that you can have are 7, 8 and 9. So what were you expected to do in this now? So there is a large number of numbers that are given, and for these numbers you find out what it hashes to. Okay, 99 it hashes to. So when I take %10 over here, this will give me 9. So it goes into, these are called buckets, 0, 1, 2, 9 are the buckets. I put it in this particular bucket, put the 99 over here. Okay. Then 25 %10 gives me 5, therefore I put it in this bucket over here. Okay. Then 33 %10, sorry, %10 gives me 3, and again I have missed 2, 3 goes into 3 over here. Okay. This is 33. And 65, now there is a problem. When I do a %10 of this, what's happening? It gives me again 5 as the remainder, therefore it goes into the 5th bucket. That means now what now? There is already an element in this bucket. Okay. Therefore there is a collision. Okay. So what do we do now? We put 65 here, and what you are expected to do as part of the program is that the assignment that is given says, as soon as you find a collision, give the position in the input where the collision has occurred. Therefore 1, 2, 3, 4, this is the 4th element, and the number of elements in that particular bucket, do not remember exactly the order, let us say 2 here, and the index of the bucket. So it is a 3-tuple answer. So this is what is expected. Now when you come to 75, %10 will give me 5 again. So it goes over here, therefore I have the number 75 over here. And what do we do now? It is the 5th element in the list, 1, 2, 3, 4, 5. It is the, there are 3 elements now in this list, and it is again the 5th bucket. Just check this order, I am not sure whether it is, this is the order in which you expect it to give, either the, but make sure that you are presenting it in exactly the same way as expected in the question. So this is the hash table question. Now where is the need for lists here? So basically you are going to implement the hash table as an array of lists as suggested in the question. Okay, use arrays and lists is what it says. So you use arrays and lists. Now what is this now? This list is the ADT list that has been defined as part of the problem. Okay. In that ADT list, it is very similar to what we did in class, except that it has also a get count, gives you the total number of elements in the given list. So I hope now you are clear how you would solve the big int and the hash table problems using the ADT list. Okay. In one case, what are we doing? In the big int problem, we are using the list like we did for the stack from the list, where the list is used as a private variable, and operations on the list are performed such that it mimics the operations of a stack. Here on the other hand, what are we doing? We are defining a new ADT, and we are defining again as part of the private part of the hash table an array of lists. Each element of the array is called a bucket, and each element of the bucket points to a list which consists of the list of elements that fall into the particular bucket given the particular hash function. Okay.